Okay, let's do some circle review. And I have my calculator ready to go here next to me. Okay, so first question is with your circle equation. So remember, anytime you see something like this, and this will be on the test somewhere, we get our x's together, which they were already there. We leave a space. It's always plus before that space. Now, because the y's are on the other side of the equal sign, when I get my y's together, I will switch the sign on both of them. And then equals everything else, which in this case is the negative 217. Again, that's already on the right side. That's why I left it as a negative. And then I leave two spaces because I need to make it equal on both sides. To fill in this space, you divide by 2 and square it. You divide by 2 and square it. Okay, now I add those numbers back over here. On the right side now, we're just going to type all that into the calculator. When you do, you get equals 16. For the left side, you're going to set up parentheses squared plus parentheses squared. X always go here, Y always goes here. This number and this number are what fill it in. That's why I always encourage you to write it like this, because those numbers are what fill in those spaces. This is now what's considered standard form of a circle. So from this, we get the center. Now in a circle equation, it's written as x minus h. So because it was a minus, this is actually a positive 8, because that's what I would have substituted in. And same thing here, it's a positive 13. The radius in the equation, this is technically the radius squared. So if I want to get the radius from that, I take the square root of both sides. So that's how I know the radius is 4. And that's that. Okay, over in number 2, I have a chord and I have a part of a radius, right? I could extend that perpendicular. That tells me that both of those are 16.7. And now I have a right triangle here, so I will use the Pythagorean Theorem to solve for the missing piece. Reminder, C is always the hypotenuse, which is opposite of the right angle. So the 16.7 in x can go in anywhere. The 20.7 is what's important because it's the hypotenuse and must go in there. So I would subtract 16.7 squared from both sides, right? We're just doing our algebra here. So when you do 20.7 squared minus 16.7 squared, oh, I just typed that in wrong. Let me try that again. Minus 16.7 squared. Okay, there we go. I get x squared equals 149.6. And then from there, I'll take the square root of both sides. So again, on my calculator, I'm just going to hit Control square root to get that square root symbol as a reminder, just in case you're out of practice. 12.2311, nearest tenth. So I look, here is the tenths place. Next to it, I have a 3, so that will keep it as 12.2. Okay. Now we're dealing with arc or angle. So this angle, I follow it to its arc. Because that angle is on the circle, I simply divide by 2 and get 50 degrees. On the right, again, I follow the angle that I'm given. The angle is half the arc, therefore if I multiply by 2, I'll go in the opposite direction. So that is 154 degrees. I'm looking for this arc over here, but I'm hoping that you now see I have 2 out of 3 pieces of the circle. So I'm going to add 154 and 107. That will give me 261. And then when I subtract that from 360, I end up with 99 degrees. So again, 360 minus 261 is how I got that 90 degrees. I'm now dealing with angles on the interior, so this is where I do arc plus arc divided by 2 to get that angle. Okay. And I just know that by looking at the picture. So this will simply be 161 plus 55 divided by 2. And when I add that all up and divide by 2, I get 108. This angle has a vertex on the circle, so this is simply arc divided by 2. So I get 45 degrees on that one. So this one is just like this. It just looks a little different. But again, I always focus on where my vertex is, and because when my vertex is on the circle, I divide by 2. When my vertex is outside of the circle, as in number 7, this is where I do arc minus arc divided by 2 equals the angle. In this case, I'm not looking for the angle, I have it. So this would be 205 minus x, because that's what I'm looking for, divided by 2 equals the angle. To get rid of that 2, I multiply by 2 on both sides. So I have 205 minus x equals 122. From there, I'm going to subtract 122 on this side and add x over to that side, leaving me with 83, which is what I was looking for, so I'm good there. More questions dealing with angle measures. So this one is kind of hard to see that it's angle measures that's actually is being dealt with. So if you were unsure, you could ask. The Regents exam would always say, you know, angle RST, all that kind of stuff. But this is just arc and angle again. So this is going to be arc divided by 2 is equal to the angle. That's how just algebra can show up in these things. So arc divided by 2 is equal to the angle. And when I do that, I'll end up with 13x plus 2. I just chose to divide both parts by 2 over there. You could have multiplied by 2. Equals 14x minus 4. I'll subtract 13x from both sides. I'll add 4 to both sides. I end up with x equals 6, and I am solving for x. I don't need to substitute it back in. On number 9, I have the vertex on the outside of the circle, but I'm not dealing with angles. I'm dealing with segments. So when you see this, this is outside times the whole, as a reminder. So 6 times this entire thing is 21, because I add 6 and 15, is equal to 7 times 7 plus x, because that's what this entire thing is. Over on the left side, 6 times 21 is 126. And then I distribute my 7, and I get 49 plus 7x. I'll subtract 49 from both sides, getting 77 equals 7x. I'll divide by 7 and end up with 11 as x. On number 10, again, I have a vertex on the inside, but I'm not going to do arc times arc divided by 2 because I'm not dealing with angles. This is where I'll do part times part. So this is simply x times 6 equals 7 times 12. It's always the parts of the chords. So 12 and 7, 6 and x. So I get 6x is equal to 7 times 12 is 84. And then I divide by 6 on both sides and end with 14 as my x. Anytime you see this, 2 tangents touching on the outside, I've called it an ice cream cone or a party hat. Those are always going to be equal. So I'm going to subtract x and add 14. I end up with x equals 12, just like that. All right, circle equations. Identify the center and radius and then graph. So when it's in standard form, this is easy peasy. Remember, the center is always opposite of what it looks. So this is going to be 2 comma negative 3. And then you always take the square root of that number. So the square root of 4 is 2. I now graph 2, negative 3 as my center. And if my radius is 2, I'll go 2 in every direction. And I am just sketching it. If you want to grab a compass, that's fine, but it says sketch. So this would be absolutely fine as a sketch to show it. Same thing over here, 1, negative 3, and it just so happens to be 2 again as a radius. So 1, negative 3, and then 2 in each direction. Moving on from there, in number 3, this is where I'm going to have to do some work to get it into that form. So to do that, I'll get my x's together. The x is getting moved to the left side, so it's positive. The 8x is getting moved, so that's going to be negative 8x plus a space plus y squared, because again I'm moving that, minus 2y because I'm also moving that, plus space. I am running out of room, so I'm going to write it way down here instead. So excuse me really quick while I fix that. Okay. Equals put everything else on the other side. So this 15 is going to go on the other side and become negative 15 and leave 2 spaces. To fill the spaces, you divide by 2 and square it. You divide by 2 and square it. So once we have that all taken care of, we have the negative 4 squared is 16. That comes over here as well. The 1 squared is 1, so that comes over there. This ends up being 2, I think. Sounds about right. Yeah, this is 2 over here. And then remember, this all goes in as a minus 4. You don't change the signs here, that just comes down. So now my center is 4, 1, and my radius is the square root of 2, which might be frightening at first, but always check to see if you made a mistake, and I very well could have. I'm sure one of you will tell me if I did, but I think I'm right. You would just approximate this to 1.41, okay? And that would give you a good idea of where to graph it. So 4, 1 is my center, and then 1, just shy of 1.5. So, right, I'll just go 1.5-ish in each direction. And there is my circle. Okay, 4 squared is 16, though. 1 squared is definitely 1, and 16 and 1 is 17, so I'm pretty sure I'm good. Okay, but if that happens, it's okay. No big deal. So now, again, get my x's together. This time I'm on the left side of the equation, so all the signs will be kept. So my x's are together, I leave my space. My y's are together, I leave my space, and then that 11 is going to become negative because I got to move it to the other side and leave 2 spaces. Divide by 2 and square it. Divide by 2 and square it. So 16 and 4 come over. I have 9 on this side. And then remember, those numbers, this was positive, so is this. So this will read x plus 4, this will read y plus 2, and the 9 came from adding all of those. My center is therefore negative 4, negative 2, and my radius is 3 because the square root of 9 is 3, and remember I do the opposite to get the center. Negative 4, negative 2, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3 give me the sketch of my circle. Okay, there, again, that's guaranteed to be on there. It's been there every time, so be ready for it. Measure of arc XV. XV is this arc right here. These are central angles, so I really just need to know what that is to be able to add it to 70. In this case, I have 90 here. Okay, so what I'm actually going to do instead is just focus on this being part of 360. I know this is 145 and 90, so I'll add 145 and 90 to get 235. And then I'll just subtract that from 360 to get my answer. There are lots of different ways to get the answer for this one. I just typed in the wrong number to my calculator. Whoopsies. So I end up with 125 degrees. Okay. Moving on to angle EBF. EBF is this angle right here, which is going to be equal to this arc. Again, I have every other part of the circle, so I'm going to add up 111, 45, and 115. Once I do that, I end up with 271. So I subtract that from 360, and I have 89 degrees for angle EBF. And those are just central angles and circles adding to 360 while I turn the page here. Okay. So again, this is like the first question we started out with. So we have x there, x there. This is the Pythagorean Theorem. So 7.7 squared plus x squared equals 12.5 squared. I've already solved this. You can solve from there, but that's the setup, and you get x by itself. Same thing here. 12.9 has to be your hypotenuse, and then 7.2 squared plus x squared goes from there. Subtract and square root to solve for x. Dealing with properties again. Notice how I'm mixing it up, because you always have to be like, okay, what am I looking at? Let's go from there. What am I looking at? Let's go from there. I'm looking for this angle, which is on the circle, so this is going to be 126 divided by 2. Again, it's looking at the visual and deciding which rule you're going to apply. 48 is here, so I'm going to multiply by 2 because I'm going in the opposite direction. So this is 96 degrees when I multiply that by 2. Here, this one is a little bit tricky. I'm looking for this angle overall. So that angle, if I follow it, is half of this arc. Okay, this arc and the 260s, which are 120, right? they all add up to 360. So I now know that that entire arc is 240 degrees. So if this whole thing is 240, that angle's on the circle. 240 divided by 2 is 120. And I'm done. Okay. Again, I always go with what I start with. Okay, so here I'm given 42. It's kind of hard to tell where that 42 was meant to be. It was meant to be here. There we go. Okay. And again, that would not happen on the Regents exam. It would be labeled, this one just ran out of space. So 42 is here, times 2 is 84. If that happened to you on a mastery quiz or anything, you just ask me and I'll tell you where that angle goes. I now look for my diameter. I know that has to add up to 180, so when I subtract, I end up with 96. Okay, almost done. This is going to be arc minus arc divided by 2 because I'm on the outside here. So again, that is all you would be doing. Beep, boop, bop, beep, boop, and your answer is there. For something like this, this is also arc minus arc divided by 2, but you might be thinking, well, I don't know what the arc is there. When you have tangents, they touch on the circle in a way that it cuts it into the 2. So I know that the other arc has to add to 360 with that one. So that's how I got my 260. And then I can do arc minus arc divided by 2. Because I'm on the inside, this is going to be arc plus arc divided by 2. Again, you will be giving the values. I'm just not bothering the time right now to type this in. But you would calculate that, divide by 2, and give me that answer. This angle is on the circle, so it's going to be arc divided by 2. This is the arc I need, which makes 360 with that. So I do 360 minus 242, and I get the 118. So this will be 118 divided by 2, because again, the vertex is on the circle. On the circle, divide by 2. In the circle, add and divide by 2. Outside of the circle, subtract and divide by 2 to get the angle. This one I have to work backwards for because arc minus arc divided by 2 is the angle. So I have to go backwards. I'll end up with 130 minus x equals 90 because then I multiply by 2 to get rid of that 2 on the bottom. Add x to this side, subtract 90 from that side, and I think I end up with 40, but I am double checking here, and you get 40. So that's how you work backwards. Same thing over here, 65 plus x over 2 equals 97. You're going to multiply by 2 on both sides and then subtract to get x by itself. Same thing here, just algebra again. It's still arc plus arc divided by 2 equals the angle, and you're just still solving for x. So you work your way through that algebraically. When you're working through algebra on this one, you just need to be really careful because when you do arc minus arc, this arc needs to go in parentheses because it's a binomial. So when you do that, you'll be there. You'll multiply by 2 on both sides and get 60, but before you can move forward, you have to distribute that negative. So 42x plus 3. And then from there, you can solve for x with no problem. For 21, 22, 23, and 24, notice I don't have angles anymore, so this is either going to be outside times the whole if they touch on the outside, or part times part. Again, I'm just going to set this one up because this video is getting long, and that's really the only reason. So outside times the whole is 30 times 30. Outside times the whole is 18 times 18 plus x. When you have a tangent like that, it counts as both outside and the whole, and here you need to make sure you distribute. On this one, it's part times part. 15 times 8 equals 10 times x because of part times part. Multiply, solve. Because it's on the outside, outside times the whole equals outside times the whole. And it's that same pattern every time. 24 part times part equals part times part. I already did a few of these for you anyways. Okay, in 25 and 26, you're dealing with tangents. Anytime a tangent touches a radius, you have a right angle. And don't forget, radii are making isosceles triangles. So if that's 56, this is 56. And then from there, I know that I have a 90-degree angle. I have 56 and 56 going to 180. So 180 minus 112 is going to give me 68. So I have 68 degrees there, and then this right triangle would leave me with that by doing 180 from 68 and 90. I think it's 22. I'm right, it's 22. But I like to check with that. All right, 3 to go, and these 3 are quick. we have our tangent touching our radius, so I have a right angle there. I have this isosceles triangle, so I'm going to do 180 minus 94. And then I'll divide that by 2 because I know that what's left there is equal pieces. So this will be 43 and this will be 43. Then I have this large right triangle, so I know that all 3 of those angles have to add to 180. So I have 47 degrees there. And finally, the tangents are equal when you have the party hat. So if this is 8, this is 8, you can do 11.3 minus 8 and get 3.3. That's 3.3, so that's 3.3. 10.4 minus 3.3 is 7.1. I'm doing this in my head, so if I screwed up, just call me out on it. 7.1, 7.1 party hat. 5.4, 5.4 party hat. To get the perimeter, you add all of those numbers up at the end. And 28, again, I think I already did this question earlier on it, but it's a duplicate. Whoopsies. Anytime you have a party hat, you set them equal and solve. So you end up with x equals 12. Circles is a lot, I'm fully aware of that, but they are important. Have a great day.